section 5.6 is finding rational zeros. So the first thing, and probably the most important thing, is you need to know what in the world rational means. And, well, zeros too, but I'm hoping you know what zeros are. So zeros, of course, are x-intercepts or solutions, places where your graph crosses the x-axis. Rational numbers would be anything that can be written as a fraction. So, for example, 3/2 or 1.5, that's a rational number. 2/3, which is 0.66666 repeating, of course, that's rational. 4 is rational. It can be negative numbers, of course, so like -7/10. I think you get the idea. So a rational number, and I could also write it as a decimal, 1.5, -2.87, etc. Those are all rational numbers, so they're either as a fraction or as a decimal, and they repeat or they terminate. Okay, so that means irrational would be numbers that don't terminate or repeat. Of course, your one everyone knows is pi, and we know what that's 3.14, da 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 da, goes on forever with no repeating, so it is irrational. The square root of 3 is approximately 1.73, da 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 da. That's an irrational number. If I have like the square root of 9, that would be rational, because you know the square root of 9 is actually just 3. So don't think that any square root is irrational, but that's what it is. So in section 5.6, you're going to be finding rational zeros, which means you're going to be finding zeros that cross the x-axis at some point that terminates or repeats. And if they're irrational, those will be found by getting some polynomial function down to possibly a quadratic, and then that quadratic can be solved to find any other irrational zeros. The first thing you should always think about when you're looking at a function is how many zeros should this polynomial function have? And how do I know if they're all real or not? And if they're real, remind yourself that it's going to cross the x-axis, and if it's not real solutions or zeros, then they're not going to cross the x-axis. So on this one, the first thing, how many zeros should this polynomial function have? And that is all dependent on the degree of the function. So if you have a third degree function, you should have 3 zeros. So it's very easy to tell. There's no surprises there. Okay, then the next question, how do I know if they're real or not? And I'll tell you this. The math behind knowing if you have real or imaginary solutions is actually quite detailed. Good news is right now in Algebra 2 you're not going to have to decipher that, but when you get to pre-calculus you will. So right now, how do you know if they're real or not? You're going to pick up your awesome graphing calculator and take a look at it. Okay, so I'm just going to say graph it. Okay, so when I pick up my graphing calculator, and pause the video, do this also just to make sure that you can see it. And I'm just going to kind of sketch what I see on my calculator. This is what I see. Now, I know that this is a cubic function and it's a positive 2, so I know that a positive cubic function looks like, you know, something like this. So if you can't see it on your calculator, adjust your window knowing what it should look like. This one, if you just do a standard 10 by 10 window, you pretty much see everything you need to see. So how many times does this polynomial function cross the x-axis? 1, 2, 3. So I know all 3 of my solutions are real. Okay, so I have 3 real solutions, but how do I know if they're irrational or rational? How do I know that this point right here isn't the square root of 3? Maybe it is, or maybe it's just 2.5. So it could be irrational, it could be rational. So knowing that, other than using the zero feature on your calculator, we're going to talk about how you actually figure out what those zeros are. Okay, so this one a little more quickly. How many zeros should this polynomial function have? Well, if I look at the function x to the 4th plus 3x cubed minus 2x squared plus 8x, well, my degree is 4, so I know that I should have 4 zeros. How do I know if they're real or not? Well, I take a look at the graph. So if I go to my graphing calculator and go ahead and do this, this is what I see when I graph it. And I think my y is set at like, I don't know, -60 or something, just so that you know. But otherwise everything's pretty standard 10 by 10 here. And okay, well, how many places does this quartic fourth degree function cross the x-axis? Well, 2 places. So I know that I have 4 zeros, but only 2 of them are real because they're crossing the x-axis twice. Well, what do you know about the other 2? They have to be imaginary. Okay, and there's no guessing about that. If once you figure out how many times it crosses the x-axis, whatever's left over, those solutions have to be imaginary. There's nothing else about that. Now, how do I know if these 2 are rational or irrational? That you don't know without actually calculating the zeros on your calculator, which we'll talk about. Another good thing to think about is how in the world am I going to find these imaginary solutions? So here, if I knew what these were, and let's just say that they are rational, I could use synthetic division on my 4th degree function using this 0. That would get me down to a 3rd degree function. Then I could take that 3rd degree function and use the other 0 to get down to a quadratic. And you all know how to solve a quadratic function, and after I solved that quadratic function, it would give me my other 2 imaginary solutions. Okay, last one. How many zeros should this polynomial function have? You should get this. You should have this, excuse me. So it's a 5th degree function, so I know that I should have 5 zeros. Okay, how do I know if they're real or not? Well, again, pick up my graphing calculator and go ahead and graph this, and I think, I don't know if this helps or not, but I think I set my x min and max to 50 just to kind of get a good feel for this, and then I think my x min and max were at 10s, and then I saw something like this. And I know it's a 5th degree function, and I know it's positive, so I know it should look like a cubic function. And how many times does it cross the x-axis? Well, 1 time. So this one, I know that I have 1 real. What do I know about the other 4 solutions? Well, they have to be imaginary because they're not crossing the axis anywhere else. So on this problem, how in the world am I going to find those 4 imaginary solutions? Well, I take my 1 real solution and I do synthetic division to go from a 5th degree to a 4th degree, and then I cross my fingers that that 4th degree function is possibly factorable and that those factors might give me all 4 imaginary solutions. If not, I promise you that right now in Algebra 2, you won't have to try to figure out those 4 imaginary solutions if it's not something you can solve algebraically.